Good morning, students. Today we will do the importance of relation between electric field and electric potential. Moreover, we will do equipotential surface. So first of all, let's find out the importance of E is equal to minus dV upon dx. If you remember, in the last video, we have derived this relation. What's the importance of this relation? The electric potential due to a point charge q at a distance of x is given by V is equal to 1 upon 4 pi epsilon naught q upon x volt. We have already discussed this in the previous video. If I apply this relation using E is equal to minus dV upon dx, if I use this, we'll get E is equal to minus d upon dx within bracket 1 upon 4 pi epsilon naught, it's q upon x. So when you differentiate this, you'll get E is equal to 1 upon 4 pi epsilon naught, it's q upon x square. Why I'm doing this? With the help of this relation, E is equal to minus dV upon dx, you can easily come to know about the electric field intensity at a point P. That is equal to E is equal to 1 upon 4 pi epsilon naught q upon x square. Now if you compare this with this is a potential, and for potential it's q upon x, for intensity it's q upon x square. Keep this in your mind. Unit is volt, unit is Newton per coulomb. Coming on to the next part. Equipotential surface. What do you mean by equipotential surface? Let's deal with this. What is equipotential surface? We say any surface over which the electric potential is same everywhere, is called equipotential surface. What I'll do, I'll take a point charge here. I will draw equipotential surface. These two are equipotential surfaces because I have taken a plus q here. Lines of forces are passing normally to the surface. इसको बोलते हैं हम line of forces. Now, equipotential surface. The important property of equipotential surface. Now, I have about 3 properties. The first property is no work is done in moving a charge from one potential surface to another potential surface. Because the potential दोनों का same है, there will be no work done. So, first one is no work is done in moving a charge between any 2 points on the equipotential surface. Second is what? Second is the lines of forces. You can see lines of forces. These are lines of forces. Are mutually perpendicular. They are passing. They are perpendicular. Are everywhere. They are making 90 degree. And third one, you can say no 2 lines of equipotential surface intersect each other. That means they are parallel. Third, important relation now. Again, we'll do kinetic energy of a charged particle accelerated through a potential. I'll write here kinetic energy of a charged particle kinetic energy of a charged particle accelerated through a potential difference in electric field. In electric field. This is what we'll do. Suppose a test charge Q is placed in electric field E. I have placed a test charge Q in electric field E. So this test charge Q will experience a force, and the force is given by F is equal to QE. This test charge is having mass. It will move also, so it will have acceleration. So I can write this. The acceleration of the charged particle is given by, A is equal to F upon M. Now I'm going to put the value of F here as QE, and I'll get A is equal to QE upon M. Since E is constant, A will also be constant, so motion becomes uniform. You can say the motion is uniformly accelerated. Why it's uniformly accelerated? Because E is constant here, so A is constant. When acceleration is constant, the body will move uniformly. Now, when I say the motion is constant, I'll assume that the particle is moving from rest. Let a particle, a charged particle, is at rest. Now, when I say it is at rest, that means U is 0 and its velocity becomes V after traveling with the distance, x distance. Then I will use a formula V square is equal to U square plus 2AS. I'll use this formula. Initial velocity is 0 because the charged particle I am assuming to be at rest. Your S becomes x. Therefore, V square is equal to 2AX. In this case, I'll put the value of A. This value of A I'm going to put it here. I'll get V square is equal to 2QE upon M into X. I'll name this equation to be equation number 1. If V is equal to potential difference between the starting point, which is starting point, and the point at rest, and the point at X, if V is a potential difference, then E is equal to V upon X. Now this equation, equation 1. Now equation 1 becomes, now what I'm going to do, I'm going to put the value of E as V upon X, and this equation becomes V square is equal to 2QVX upon MX. Your XX get cancelled and you are left with 2QV upon M. This is V square. We can easily find the velocity now. The velocity of a charged particle moving in electric field is given by, therefore V is equal to, you'll get under root 2QV upon M. This is the velocity. But we need to find the kinetic energy. Since kinetic energy of a charged particle is given by half mv square, therefore kinetic energy is equal to half into m into square of this. So it's 2qv upon m ka under root ka whole square, which will give kinetic energy is equal to half m 2qv upon m. Mm cancel, the 2 cancel, therefore kinetic energy is equal to qv joule. Just remember this. Please note one thing. If charge is given as 1.6 into 10 to the power minus 19 joules and V is given as 1 volt, therefore kinetic energy is equal to 1.6 into 10 to the power 19 joule. And could you please tell me what does this stands for? This 1.6 10 to the power 19 joule is equal to 1 electron volt. Just remember this. Exam में पूछ सकते हैं. Derive this. So I want small this derivation. Clear? After this, I will do in my next video. Thank you.